afternoon. So now we will start with ANSYS SolidWorks software. So hydrokinetic turbine modeling through the SolidWorks software. So before going into that, just I promised you that I will discuss about the different types of turbine. After that, I will select one type of turbine, and then we will I will try to show you how it can be prepared in a ANSYS modeling software. So hydrokinetic turbine, there are different modes of classification. First one I have already discussed, that based on the force applied on it, it can be classified. So that hydrokinetic turbine can be classified as drag based turbine. Hydrokinetic turbine can be classified as lift based turbine. Now this particular turbine again can be classified based how they are being oriented. That means what will be the axis of rotation of this particular turbine. And then this type of turbine again can be classified based on where it is being applied. So whether it is marine kind of turbine or tidal kind of turbine or it is river flow turbine. So based on this, different type of classification can be obtained. Apart from this, there are different combination of all of type of turbine it is being made whenever it is found suitable for application of a particular application. So first of all, see this particular here in this particular figure, it has been shown that how this particular hydrokinetic turbine has been classified. So based on this flow, it is passing through the blade. So when a particular when fluid flow is passing through the blade, if it is across the axis, so it has been called as the cross flow type of turbine. And if it is along the axis, then it is being called axial flow turbine. So across the axis, suppose fluid is flowing from my left to the right, and if your axis of this turbine is like this, just I hold my pen. So blades are installed here like this, and fluid will be coming, striking the blade, and it will compel the turbine in this type of rotation. So this I can say the fluid flow direction, it is across the turbine axis. Now this axis alignment, it can be horizontal, this axis alignment, it can be vertical, but again it is across the fluid flow. So it will come under the cross flow type of turbine. Now fluid is coming in this direction. Instead of this axis, if I change the axis in this direction, so whenever fluid will be coming, blades will be like this, and it will be passing the blades, and after passing the blades, fluid will be going along the axis. So this I will call it axial flow direction of the particular turbine. So again, this axial flow type of turbine, it may have this type of horizontal orientation, it may have some kind of inclined orientation based on the application and based on the situation. So here in this first classification, I just want to change the pointer. So this first classification, so it will be cross flow and axial flow. A cross flow, I just told you, it may be vertical axis, and otherwise it may be in plane axis, or axial flow, it may be horizontal, it may be inclined axis. So vertical axis turbine, again vertical axis turbine, suppose your axis is like this, fluid is coming from my left to the right. So now this particular turbine, all this type of turbine, it is a vertical axis but cross flow type of turbine. Now its blade, it may be this type of shape, its blade, it may have some different type of shape. If this type of shape is there, that means S type of shape, we generally call it drag based type of turbine, or blade may be straight also. So fluid will be coming, it will be coming and striking the blade in this manner, and after that, based on the orientation of this particular blade, fluid will glide over the blade and it will try to pass over the blade. So this type of turbine, it may be either, just I told you, drag based type of turbine, and if the cross section of the blade, if you found it aerofoil, then it will be your drag based type of drag based type of turbine. So here some classification again has been shown. So helical type of blade, this is Gorlov blade, then Darius type of blade, this is also आपका drag based turbine. Savonius turbine, this is a this is a lift based turbine, this is also lift based turbine, and Savonius is the drag based turbine. Again Savonius turbine, if I consider, it may be conventional Savonius turbine, it may be helical Savonius turbine. That means blades are like this, conventional, one blade will be like this, another blade will be like this, and some of the turbine it may happen that at the bottom plate it will be like this whenever it is reaching the top plate. So in a turbine, if you see this particular picture is already there. So this is the conventional turbine, this is the bottom plate, this is the top plate, this is the axis of this turbine, and this is the blade. Blade is having a S shape. Now this is the conventional one. So starting from this bottom to the top, it is having it will start from this particular coordinate and it will end up with the same coordinate if you see it from the top. So if you see it from the top, this particular point and this particular point will be overlapping with each other. Now if I see this particular turbine, this is a helical Savonius turbine, what will happen? If you see it from the top, the same position of this blade, it will start from here, corresponding to point, you can say it here, and whenever it end up, this has been already got a twisting angle. So just like this, I have hold it like this and I have given a twist. So at the bottom it is remaining there and at the top it has been twisted. So this particular point, if we see from the top for a conventional one, so this point and this point, if you see it from the top, it will be overlapping with each other. But when I apply a twist, so what will happen? This point it will remain be somewhere here, and due to the twist action it will be here in this particular point. So there will be a difference, and if I draw two lines from this point to this point, so it will make an angle. That particular angle will be called twisting angle. So this twisting angle, so it will be imposed here. This will be called now helical Savonius type of turbine. Now there is another one, modified Savonius turbine. In this modified Savonius turbine, if you can remember, last day I have talked about some overlapping ratio. Overlapping ratio, that means two S shape was there. Normal condition, there will be a shaft here, one blade will be here, another blade will be here. Now in this particular type of turbine, for this particular design, there will not be any kind of shaft, rather one blade is there, another blade is there with an overlap part. So instead of shaft, this particular turbine, it is holding through this end and top and bottom plate. So this top and bottom plate actually holding this particular blade and this particular blade, and there is a passage in between these two. So fluid can come, it will strike and it will be gliding over this particular blade, and then backside it can come out. So that is the passage intentionally being created due to some hydrodynamic action. So those exercises separate, but I would like to tell you such type of different parameter changes is being done in order to tackle different type of problem in general being arised when we design a particular turbine. Now before going into the design, you have to first figure out what should be your design of your turbine and why you are choosing that design. Anyway, before going to that, I would like to tell you another further classification of the Darius turbine. Darius Darius turbine already you have seen. So again, Darius also few classifications are there based on their pattern. Squirrel cage Darius, H Darius, Darius with the carved blade, the different type of twisting angle, different type of angle, different type of curvature. Those are imposed on the conventional Darius, and you will get different model of the Darius turbine. Now this cross flow turbine, along with this there are some marine turbine. Marine turbine doesn't have also some conventional shape. It may be anything, means which will be having the cross flow sort of characteristics for this type of marine turbine. So I will show you later in some tutorial some other type of model of commercial marine turbine also there, maybe in some, definitely in some other your presentation, maybe in other context, then I will again make you remember that I have discussed those things. So hydrokinetic turbine, axial flow turbine, again it may be horizontal axis, inclined axis, bound mooring. That means how those are being anchored. So so those also can be a different criteria. Basically, where you are planting those particular turbine, how you are planting. You are planting differently those particular turbine because of some surrounding characteristics. So that will also influence the design of this particular turbine. So these are the some example where this type of turbine is being installed. You can see 350 kilowatt of capacity of turbine is being installed, Hastings Hydrokinetic Power Station US. Some open center turbine Ireland, 250 kilowatt to 1 megawatt capacity was also there. New Energy Corporation Canada, 5 kilowatt to 250 kilowatt power production capacity is available there. This is a laboratory setup available in our laboratory. Here actually this is laboratory experiment. Here actually we try to find out with a particular fluid flow velocity how much will be the torque it is producing, and then we can calculate the how much mechanical power it is calculating. That means shaft power, how much will be the shaft torque. So we can regulate the fluid flow and then we can find out how much will be the power generated in the turbine axis. Simultaneously we can put some of the weights here, so that basically we try to simulate how much electrical load is imposed on this particular turbine in real condition, and accordingly we are putting here mechanical load, and we will try to find out in different loading condition, that means in actually different speed, how this particular turbine will giving you the output. So what will be the efficiency of this particular turbine. So if you can remember, we have our efficiency curve. In the y-axis there was a coefficient of power or coefficient of torque, and x-axis there was TSR, TSR, tip speed ratio. That means tips ratio to the fluid flow velocity, the ratio between these two. So the tip velocity, that is actually blade velocity. Blade velocity, it is occurring because of the r radius from this point to this point multiplied by the omega. So it is rotating with an omega. So this omega is actually controlled by the weight imposed by this. You can see this weight here. So if I increase the weight here, so maybe in this particular velocity it is remaining constant by I am increasing weight or decreasing weight. So what will happen? I am giving the load on this particular turbine, even if the inlet condition is same for all the cases, but this particular turbine may not rotate with the same speed. So it will have some different speed. So this corresponding to the different speed, your TSR value will be changing, and because of the different speed, your power which is being generated in this particular shaft, that is also will be rotating. These are not linear. This is non-linear. Because of this, we will be getting the non-linear curve. Even if it was linear, then we could have got a straight line, but it is non-linear. So in this manner, basically we try to find out what is the best position, surround this particular best position we would like to run our turbine. So what should be the best speed, and then how much will be the maximum power output we can achieve through the turbine. So this is the exercise in generally we perform before installing a manufacturing a particular turbine and installing it into a site, because manufacturing a turbine is being difficult. Before that, we generally prefer to exercise it through simulation, and after getting the satisfactory result, then only we go for the preparation or making of this particular turbine, and then we implement as a in a laboratory or as a pilot project. So this is different types of your these Darius turbine. These are all given, and again this is in the morning I have discussed about some in-pipe hydropower, in-pipe hydropower or in-pipe hydrokinetic system. In-pipe hydrokinetic system, you can see this is actually having a cross-flow nature. Cross-flow nature, you can say number of blade which is present in a conventional Savonius turbine, that is 2, it may be 3, I can increase more. So that particular Savonius turbine, if there are more number of the blades, I can, if I wish to install it in this within the pipeline, then I have to modify the blade. Instead of rectangle, I have to modify the blade in this manner so that it will have a spherical shape here. Then it will be able to rotate inside this cylindrical domain. So this type of modification basically I need to perform. So this type of modification also will be applicable if suppose this squirrel cage or maybe Gorlov or maybe this Darius. These Darius actually I can place it here in this particular area and I can rotate, because if it rotates, its shape is looking like that, it will have an impression after rotation, it will give you a spherical sort of impression. But if I would like to use this squirrel cage inside this particular pipeline, then I have to make such a shape, I have to give some curve here, so that whenever it will be rotating, it will have a spherical impression, so that the fluid, less amount of the fluid will be lost while it will be passing through this particular turbine. So maximum amount of the energy can be harnessed. So those type of small modification in generally being made, and before implementation we generally go for model testing through simulation. So now we will start the CAD modeling. We have chosen the SolidWorks. I will try to give you the few operation in the SolidWorks. I hope you will be able to do it if you have SolidWorks. There may be some student version SolidWorks, or in your institution there may be SolidWorks. So there you can practice this particular exercise. So first thing will be, here I have chosen a horizontal axis hydrokinetic turbine. It has been observed that horizontal axis turbine will give you more efficiency than vertical axis turbine. In vertical axis turbine there are few disadvantages. Horizontal axis turbine there are few disadvantages or advantages. The prominent disadvantage in the vertical axis turbine is, vertical axis turbine will be like this. It will be fitted in a frame. It will be fitted in a frame. Frame will be across the river. Suppose this is the river, and you have to put a frame over the river. I hope that particular river will have a limited width, so that I can put a frame it here, or otherwise in some other manner I have to prepare those civil structure, so that I can put a frame like this. Now there will be bearing here, and on this bearing the shaft of the turbine will be mounted here. So whenever fluid will be coming, this particular turbine it will be rotating like this. So whenever fluid will be coming, it will have a thrust. So always it will have a tendency like this. So there will be unbalanced thrust on this particular bearing. So always there is a failure tendency or misalignment tendency, or creating vibration in this particular domain if this strength of this part is not that strong. So that is the main problem if you are using a vertical axis turbine. In our laboratory also we have tested vertical axis turbine, but after few days, few months, we have seen that instead of behaving it vertical, it actually had been tilted. So now whenever it is being tilted, so force which is striking the blade, it will not be uniform. So force which is striking in the lower part of the blade and force striking with the upper part with the blade, the same blade, it will be something different magnitude. Then it is creating problem. So then it is again starting torque problem will also be arised in this particular area because of this non-uniform sort of blade. Again, whenever fluid will be passing over a particular channel, the fluid which is interacting with the solid surface, that means river bed, it will have a lesser velocity, and the fluid which is passing through the almost free surface area, it will have a higher velocity. So that is also creating problem. So all this problem can be taken care of if I place a axial turbine. So an axial turbine, its blade will be like this. So all the blade once at a time, whenever it will be, suppose here there is a velocity, fluid flow velocity something, suppose 1.1 magnitude. Suppose here in this portion it is 1 magnitude. So whenever this blade is taking this particular one, whenever it is rotating here, coming out here, it is getting the 1.1. At least each and every blade it will be encountering with the same velocity at a time of the rotation. and as well as this particular tilting problem, it will not occur. But there are some other problem. Whole shaft will be immersed into the water in case of the axial turbine, and it will create the problem. Electrical gadgets which I can install in case of the vertical turbine above the water, that I cannot do in case of the horizontal axis turbine. Then I have to make arrangement, either you change the direction of the shaft rotation through bevel gear maybe, then again if I am putting bevel gear, so what will happen, there will be loss, mechanical loss, or otherwise you have to prepare some sealed environment to keep your generator here, and again it will be creating the problem. So this type of things, as well as the impurities which are coming out, it may clog the bearing, because whenever you are putting the horizontal axis turbine like this, it will be under the water, and total bearing, at least one bearing must be here. So there is a tendency, if you cannot protect the bearing, so it may be clogged due to the impurities which is carrying out of the flowing fluid. So that may problem. But in case of the vertical axis turbine, since total set is above the water, so that problem will not happen. So there are different problems. So that those particular problems, some advantage, some disadvantage. You have to check which type of model is suitable for you. For our exercise, we have considered so many vertical axis problem exist maybe in the internet. So we have chosen that why don't we go for the horizontal axis turbine. So we have chosen a horizontal axis turbine for this analysis. So in a horizontal axis turbine, next we will see what are the different design parameters, because as per those design parameters we will try to give some command in the SolidWorks to prepare those command. Apart from this, there may be some other design parameter you are interested, and you have to find out the way how you would like to incorporate those things into the model. Second one is whenever we are talking about a turbine, in case of this particular turbine, horizontal axis turbine, here horizontal axis axial turbine basically, here hub is having a very important role. Hub, it is a central part of the shaft, actually frontal part of the shaft, which will be first encountering the fluid flow, and then blades will be somewhere here. First there will be hub, then blades will be here in general. Your design may be varying some other way. So hub is the important part. Whenever fluid will be coming and striking this particular hub, so then it will try to form this type of passage, and then it will be encountering the blade. So you have to design your hub in such a manner so that your fluid may not make any hindrance of rotation of these particular blades. So in this manner you can design the hub. So there may be literature available in the internet. You can go through what should be the different criteria of hub. We have selected here a specific value for the hub, and we have drawn this, because our purpose is to show how to draw, not to going through the research. So I will show you the process to draw, and you will adopt it, modify it, and you will use it for your own. Now when we will be drawing the hub, after that what we will be doing on the hub, I just told you hub is the modified part of the shaft. So next will be blade. So blade is the most important, because in the blade itself your linear velocity of the fluid, it will be converting ultimately into the rotation of this axis. So that is the most dynamic part. So that particular blade we will be drawing first. So initially one blade we will be drawing. After that, since we will be going to draw a 3D model, so after that we will try to draw the multiple number of the blades. Again, how many number of the blades you will be selecting, that is as per your calculation. So you will do the calculation. There are lots of parameters in the coming under the design parameter of a particular turbine. Accordingly you will select. So all the parameters are associated. Is are not, nothing is straightforward. Means if I select, if I increase the number of blade, it will behave like this, not like this. There are few common zone in between the variables where you can say those are the common and some overlapping zone. So that you have to take care of. Now after that you have to smooth the your drawing, smoothing of the drawing, because whenever we will do certain operation, so some part may exist which will have the sharp edge. So you have to smooth out the those particular edges. Then you have to draw the multiple number of blade. Now after preparing all this total thing, now we have to prepare this particular drawing for ANSYS simulation, because in ANSYS here we will be drawing the model and then we will be importing into the ANSYS for analysis, CFD analysis. So before going into that, we have to define a few zone, and after defining those particular few zones, we will be discussing it later. Then it will be prepared for the analysis in the ANSYS. So let's start with the design parameter of this horizontal axis turbine. So this is the isometric view. In this particular isometric view, here 4 number of the blades we have considered with a half, and this particular blade, if you take the cross section, it will give you a rectangle cross section, simple. And obviously that rectangle cross section may be bended one, because there is some bending operation we have given. So this blade thickness, it will be uniform throughout the blade. This is the hub. Hub is having a taper cross section. In this way, taper circular cross section. You can choose any shape. And now there will be a hub diameter also. If you put smaller diameter, it will behave some different manner. If you place bigger diameter, it will behave in different manner. You can check how it will be behaving by increasing or decreasing the hub. Now what will be the length of this particular blade, because ultimately along with the length itself, the diameter of the turbine will be defined from the rotation axis here to the extent of this blade. That will be ultimately called as a diameter, this particular turbine diameter. But whenever we will be talking about this particular blade, we will be calling it the blade length. But blade length starting from this axis of the rotation, ultimately it will be contributing to the turbine diameter. So now this is the front view, this is the top view. So from the top view, if I see, it will be looking like this. From the front view, that means from this part to this part, if I see, so it will be looking like this. For left hand side view, if I see from this type to this type, it will be looking like this. Right hand side view also will be same, symmetrical. So if I see consider a side view, so length of the hub, it will be like this, and you can define the what will be the distance from the tip of the hub from which this particular blade will be starting, and what will be the length actually you can say starting from this part to this part, what will be the extent of the blade in this particular direction along the hub direction. So and now if you see this particular part, this is a central axis or axis of rotation. So definitely this axis of rotation will be passing through the blade somewhere here. So now if I consider this part of this blade, it is touching this axis, and this part of this blade is touching in this axis initially. Now I have given a twist like this. Initially it was like this, now I am giving a twist like this. So now after giving that particular twist, basically this type of alignment of this blade will be present here. So now it is looking like this. Along with this, there is a pitch angle. This pitch angle, it is the angle which is after giving this total rotation about this axial rotation, it is the pitch angle. Now this part is, if you made it fixed and now rotate, twist the top part, then only it will be the twisting angle. So two angles is located here, and these two angle will give you one will be the pitch angle, another will be the twist angle. After giving this twist angle and this pitch angle, now another also operation is being done. Suppose this is your hub, and this is first initially suppose initial condition your blade is like this, but if you place your blade, it will not rotate. So what you have done, you have introduced a pitch angle. Then what you have done, you have introduced a twist angle. Then third one, I am introducing another angle which is bending angle. These are all combination. You can put any two out of these three, or you can put any another angle as per your wish, and you have to check how it is behaving. So these three angle it has been introduced here. One is pitch angle, another is twist angle, another is bending angle. So this all in combination of all these three, basically this particular model has been considered or imagined. Now we will be drawing this, and then we will prepare this particular drawing for our operation, ANSYS operation. So first of all, if this is actually SolidWorks dissolved system, we have a 2024-25 version. So if you on this particular, so see there is some time limit. If I could draw it here, it was not possible to complete all the exercise within 1 hour or 2 hours. It requires time. So that is why what we did, we have performed this exercise, we have taken the snapshot, the main part, and then we have sequenced, we have made it a sequence PDF so that you can use it later, kind of note. So I hope it will be helpful, because live demonstration is required so much of time. So live demonstration was not possible here, so we have made it in this particular manner. So here we will be using the part drawing. So different parts we will be drawing, so we will be using the part drawing, and then you have to click OK, so it will enter, and then this interface will come. Now if you see, there are different ribbons here, means and with different options. So these are the ribbons, these are the option. File, if you have unsaved file, saved file, so you can open it. Editing, view, insert, these are all about the files. Different tools are there, and some the tools are there directly, that will not be useful for this particular drawing. Here new project, inception of the project, you can start with a project. But here, if first whenever you will be drawing, so first thing we in general we perform is, we generally clear the background, because normal condition is a default view is there, some faded view. We clear this particular view to the white one, because sometimes we need to take the photograph and we need to use it in our document. So we generally avoid this one to make it background. And second thing will be, you have to select your proper unit, because without unit there is no meaning of drawing. So actually measurement should be proper, then only your drawing will be fruitful, useful. So here actually in this particular part IPS is there, this particular part you have to click here, and there is IPS means inch, pound, second. Here mmgs, millimeter, gram, second. This we have taken, we have drawn our drawing in millimeter, because in our case our drawing we have made within 300 millimeter diameter, within, below. So we have chosen it millimeter. So if your drawing is higher in terms of the meter, so you could have choose this MKs. So that will be based on you, and that will be again based on the fluid flow velocity and water depth available in your implementation area, for which basically you are trying to find out what should be the performance of the turbine. So accordingly, if you wish to scale down this particular drawing, then also will be work. So you should have that calculation, that how much you are scaling down from your actual drawing to the your model. So those particular calculation must be present with you. Otherwise, if you are going with the actual one, so you have to select the proper unit. So once you select this proper unit, so then first thing will be, we have to choose those planes. Already I have shown you in general our drawing concept. There will be front view, there will be top view, and there will be side view. So we will choose those particular planes where we will be starting our drawing. So here in this particular part we will be choosing this. So primary planes will be chosen. So then primary top side, right side view. Here the combination is front view, top view, and right side view. So this will be the it will appear, and then you can just bring your cursor here. It will be highlighting with other color. So you can select how it will be, which plane you will be basically start drawing. Now next thing, you have to you have found out your planes. Now in which plane you will start your drawing. So in my case, I would like to draw my hub first. from which part you will be starting. So that you have to determine. So here in my case I will start with the hub. First I will draw the hub, then I will draw the blades. So hub actually I would like to draw in my front plane. So if front plane is like this, I will draw the hub here, and then across the front plane I will draw my blades. So in front plane I will draw the hub, and in the right plane I will draw the blades. That blade will come later. So here in front plane we will be drawing the this hub. So first one is the this we have to start the sketch. So whatever we are thinking or we will be doing manually, software usually try to replicate those things and try to give those names. So here is the sketch. So you can select this particular sketch. Again you can see there is a sketch option available here also. So we will be selecting this particular sketch here, and whenever this particular sketch is selected, so this isometric view it will be changed, and simple only front plane will be visible in front of you. So now in this particular front plane I will start drawing my hub. Now there is different options in inside this sketch button. In sketch button there will be line, there will be circle, there will be rectangle, there will be curves. In curve, 3-point curve, there will be spline curve, different sort of option will be there. Whenever you will get any kind of such type of button, there if this type of option button will be there, your purpose should be to click these things and you will be checking how many options are available there. So you can select your own. Now the thing is how I will draw the hub. So if you can see this particular pen, this pen is actually looking like the hub. So this plane I can draw in different manner. First I will be drawing the 2D view, then I will convert it into 3D view. So what will happen? So I can imagine this particular your hub in such a manner. If I take a sectional view, I cut it like this in the middle. So what you can see it will be looking like this. So in my case I have another option. So what I am taking, instead of cutting it half, I am making 1/4. So I am cutting here as well as I am cutting here at the middle. So axis of rotation I am cutting it here, axis of rotation I am cutting it here. So 1/4 I am getting, and that particular 1/4 I will try to draw, and that particular 1/4 I will try to revolve one other option. So that particular will be revolving about the axis of rotation, and it will create the 3D view. So this is my intention. You can do as per your wish. You can do it in other way also. This is not whole and soul, means this is not the only process to develop this type of drawing. You can do in your way. Anyway, I am showing my way. So this is the sketch we have selected. Whenever you will be selecting the sketch, what will happen? There is the left hand side, there is this type of tree will come. There you can see different types of options will be obtained. So here I am working on the font pen. So this font pen will be highlighted here, and here actually what happens, after drawing, then I have taken the snapshot, this screenshot. So already I have drawn this sketch one, so that particular sketch one is visible. Anyway, so here this is the line. Actually this line, if I bring my cursor here, it will form another sort of arrow, and that if I press it here and if I drop it down, and this particular part, actually it will be hiding some of the part which has already been drawn. So this is the option to making visible or invisible this particular line. So actually I have drawn it earlier. After that I have taken the snot, so it is showing like this. So anyway, so now what will happen, that this is the I will try to draw those particular 1/4 part of the heart. So you will start with, actually origin is the reference of all. So I will start with the origin. I will give certain value corresponding to the origin, and corresponding to that basically I will be putting these lines. So I am basically trying to draw the lines. So inside the sketch I am putting the lines, and there are different dimensions I have already plotted here. So whenever I will be drawing these things, so there are few other options will be visible. See, these are the line properties, which type of line you are considering. So anyway, after click, drawing these particular lines, and you should know the dimensions, or you can do your calculation. So you will be drawing these particular lines and you will be closing those particular 1/4 part, and then your objective will be to click this tick, green tick in the SolidWorks. This green tick will be there, or you can say this type of, or if you would like to reject this particular drawing or some other part, so you can select this cross, or if you would like to consider this, so you can select the tick. So after completion of this particular drawing, then you have to select the tick. So then your drawing will be complete. And if you can close your drawing properly, here it is very much required, because I would like to make a plane, this sort of plane. This particular plane, it will be actually rotating about the axis of rotation, and then it will form a solid body which will have a cylindrical shape. And because of this, it will form some groove. Here it will be a groove, here it will be another groove, here it will be another groove. So if you have an drawing idea, engineering drawing idea, you will understand that there one edge will be formed, there another edge will be formed, there another edge will be formed, and this will be another edge will be formed. So this type of drawing here, if you see this particular drawing, ultimately what I have drawn, it is a bit of different than this particular drawing, because later on I have changed this particular drawing. Initially I have started with this, and then I have modified the drawing to get this type of shape. So how to modify that also I also will do. I also will tell you. So because of this I have started with a bit of modify. Later on I have changed it with this particular exact figure. Okay. So now what will happen? You can see there is a smart dimension button. So say I have drawn this particular, after clicking the lines, I have selected the sketch, then lines. Out of this sketch I have selected the lines, and I have completed this particular drawing. And this particular drawing now I need to change. Before change, how much I would like to change? So I should know the dimensions so that I can change. So to get the dimension, there is a button which is smart dimension. So smart dimension, you will click it here, and if you select each and every part, those particular parts starting with the segment of the line and starting with the different angle, it will give you the measurements. So those particular measurements it will be giving, and if you would like to change this, so suppose if any portion, if you would like to change this, so that particular value it will be appearing, you can type this particular value, you can select the tick. So that particular segment it will be changing. So now you can see, so there are different other values. So this particular value it is given, the angle will also given. So if you would like to change this particular angle, select this particular angle through this particular button, and you change the value. So accordingly, suppose if I would like to eliminate this particular part, so if there is any angle in between, so that angle I can make it 0 or 180. So accordingly it will change. And suppose the distance from this point to this point is defined. If I define through the smart dimension, so that particular smart dimension value I can change up so that it will be along this particular line. So this rest of this portion, even if line segment will be there, but this will be like a horizontal. So in this manner I can change the values. So these are the values considered for this particular drawing. And after that, after completion of this particular drawing, what will happen? I told you that I will do a revolution. So this particular plane has been completed. Now I can make it a revolution. See, there are many ways, but two prominent way to convert a two-dimensional drawing into the three-dimensional drawing. One is called extrude, another is, if symmetricity is there, this type of symmetricity here, so we can go for the revolution. In extrude, suppose this is the part, this, if you see this particular drawing, so this drawing board actually is rectangle. So if I try to draw this, I will draw first rectangle. Now suddenly I found that it is having a thickness. So if I want to give the thickness, so that rectangle pale I will select, and then I will give a extrude in any direction. That direction also I can control through this particular part of the drawing. So I will give a direction. So in a particular direction, I will have that much amount of the extrude. So that particular thing will produce this particular plane into a 3D drawing. So that thing here we are selecting in different manner by giving the revolution. So this revolve boss or base that is given, and you have to select this particular plane, and then you have to give the revolution. So after giving the revolution, what will happen? This this particular hub will be formed. So now this particular hub here you can modify. This revolving options are given. So what is you want to give the revolution? You want to give the revolution about the axis of revolution is the line. This is line 9. How to get the line 9? You can bring your cursor and you can see the line, you can select it. So automatically this particular line it will be selected. And direction, here we have used blind. Here are some other options. So for our drawing, this particular option is suitable. And how much revolution I would like to give? 360-degree revolution I would like to give. Starting from this part, it will rotate and it will complete. Say, if I had half of the half, if I had to draw, so I could have made the this particular plane, and I could have give 180-degree rotation. So half of this part would have been formed. So in this manner, so basic operation is there. How you will be performing, that is up to you. So this particular thing we have given, and then basically you will be selecting this click, and then it will be completed. Now after completion, then I just would like to see this particular what I have prepared. I would like to see from different angle. I have front view, top view, side view, left hand side view, back view. So because basically I have all the views, 6 view. So all the 6 view, I have this particular option here. You have the viewing option. You click it here. You can see so many options are there. In this particular option, this is the prominent plane. Actually, from this side itself, you can see this particular picture. So picture will be inside this box, and from outside, from which side you want to see, that you will be selecting, and you can see it. So different view you can see. So after doing this, then now the thing is you have to prepare. You have to go for the. You have to give a reference in order to make the next step. So for this, first thing will be the reference plane. Any other thing, additional thing you would like to add, to define the plane. So actually we would like to create the another plane which is actually required to develop the blade. So basically we are now preparing for the blade. So far what we did, we have drawn our object in the front plane. Now I just told you I would like to draw my blades. So this hub and shaft has been prepared. Now blades actually will be like this, and it is having a twist like this. So basically blade I would like to draw across another plane. This particular plane, it will start from somewhere here and it will extend somewhere other part. So I need to create 2 more planes. One is for the starting, another is for the extent of the blade. So actually for this we are trying to do this exercise. So for new plane, whenever you will be drawing the new plane, so new plane will be selected the T. So whenever this new plane will be selected, the first thing will be to give the reference where I will be selecting. So initially it will be starting with this origin, then you have to give what will be the distance with the origin, and then you have to, you can select the existing figure also here. This face is also being selected, and there is a command. This is the distance already being given, these dimensions, and flip offset, that is also given, and ultimately you can produce this particular plane. So this you can shift these things. So from here basically you will be starting this initiation of the blades. So now see, we are selecting those particular plane where your initiation of the blades will be generated. So again, whenever we are selecting the plane, so there this in the left hand side you can see one plane 1 has been created, and this is the feature feature tree already will be there. So Earlier what we have done, all are available there. Front plane is available here, top plane and right plane, these are the plane, and origin also separately stored in the database. Now we have performed a revolve option of the sketch 1. Each and everything you can click it here and you can cross verify again. In this particular figure right now I can click this sketch 1, so I can see there will be that 1/4 part of this particular drawing which will be highlighted. So in this manner I can cross verify and accordingly I can select those rest of the part. So now I have to again give the axis of this particular blades from where it will be generated. So that particular axis you have to draw in the here in this front plane, and corresponding to this plane here this particular new plane 1 will be selected. Now another plane, this new plane will be generated, and now you can see the two plane has been generated. One is plane 1 and plane 2. One is for the initiation of the blade, another will be the extent of the blade, just I told you. So if you see this particular part, this reference part, say here also if you click it here, so here this front plane has been highlighted and other characteristics of this part that is also being highlighted. If still now if you would like to edit this portion, then also you can change this here, and again you can select this click so that it will be considered here. Okay. Now next one, suppose in the plane 1 what will be there. So you have now say you have this particular blade. Now this blade, it will have a curvature. It will have a curvature, already you have seen. This is having a curvature like this. All the curvature may not be able to draw at a time. So what will happen? You can break this particular curvature in some parts as per your known available data. So that particular parts you can draw. If some part is straight line, then you can use the straight line, and if some part is having a curve, so you can select the curve, and additionally you can join it like this. So ultimately you have to form a closed loop. You have to close the drawing because you need to give the thickness of the blade. So while you are drawing, so you have to keep it in your mind from where you are starting and from up to extent you will be reaching with this particular drawing, and it should be completed. So the plane selection would be proper. So suppose plane 1 that was starting point of the blade hub, just I have to already told, and this is the plane 2 is the end. So now you will be starting drawing this particular blade. So you have to again start with sketch. So now you can start plane 2 with the drawing and with the blade cross section, and then you have the option. I have just taken it here. I have the option, I can cross it or I can move it forward. So now draw the lines with the insert line. You have to start with the line. So basically in the sketching option, basically you have to press it here. So line will be coming, and then you will be drawing a line. Suppose it is taking a distance from the axis, and now what will happen, you will be adding a curve with this particular line. For this curve option, there are different type of curve option. So this different type of curve, here we have chosen 3-point curve. So prepare a curve, there are different option, maybe 2-point with a radius, maybe 3-point, maybe multiple point spline curve. So different type of option is there. So 2-point, suppose there is 2-point and I want to put a circular part, so I need to define a radius. So if I increase the radius, so it will be flatter. If I decrease the radius, so that particular radius, it will be curve will be more curvilinear. If I increase the radius, so that means to the infinity. Actually curvature means part of circle which is having an infinite radius, that will be behaving as a straight line. So that particular concept will be used. You have to understand what you are actually trying to do. So accordingly you will be selecting 3-point of curve. Here I have selected. Now once I give the 3-point curve, so it will be appearing like this. So basically one part of my blade I have started it here. Now I am basically through this particular smart dimension I can basically change the dimension, because we can start with any random data, then I can change the data as per my wish. Now you can see after putting this particular value 130, so what is happening, initially I have started with a small part of this straight line, then I have joined it with a curved line. So both the line I have used, and now I would like to complete this particular part with another curve, say. So we have tried multiple number of the options what is possible to fit with this particular curve, to show you that this type of curve also you can use. While you will be drawing, you can select as per your wish, as per your drawing. So actually here I have next curve, actually I have used spline curve. So with the spline curve I have completed this particular drawing. So initially it was like this, then this was like this was like this, and finally I have drawn it like this. So when I drawn it, I have to ensure that that is made a closed drawing form, even if line and curves are associated with it, but this particular drawing must have some close formation. So otherwise it will be very much difficult for us to give that thickness of this particular blade. So initially you can see the thickness of this particular blade, the blade profile has been completed, basic blade profile. So now it has been named as a sketch 2. So I have given this particular blade as a sketch 2. So now, okay, fine. You can take a 5-10 minute break, then next part we will start. So we have prepared the basic shape of this particular blade. So now our objective will be to give the thickness. So I just told you earlier, so converting a 2D shape to the 3D shape, there are few ways. So here we will be using the extrude option. So in this extrude option, basically we can find out from the again feature. So here is there this feature. So this extrude, for this extrude, so boss extrude, you can see the boss extrude here. So select plane, so you have to select the plane, and direction, you have to select the direction. So here we have selected the mid plane option, and this how much will be the thickness of, so that also you can give through this, and finally you can give this particular thickness. So now we can give, so if we in our drawing was a very basic drawing, basic shape. So you can see there is one curve, there is another curve. Even if two lines or one line with one curve, or one curve with one curve join with each other, so apparently in a 2D figure it will not be observed, but whenever it convert into the 3D, so through this particular point a line will be generated along the thickness. So that will be the sharp edge. So that particular sharp edge you need to remove. So otherwise it can create different type of problem in the geometry. So during the manufacturing as well as during the fluid flow interaction with this particular solid surface, it can create different type of flow diagram. So that we need to change. So here we would like to change the surface. So surface change through filleting or rounding. So we would like to provide a fillet here in this zone as well as in this zone, wherever required. So this particular filleting we are giving that where we would like to fillet and which type of fillet. So here different type of filleting option is there. We would like to select this one, because if you consider see this particular figure, so this particular figure actually belongs to this particular part. So even if there are other type of filleting option also there, anyway, so here we have selected this particular part which part we will be selecting. So here through this, if we select this particular part, so automatically it will be taking as a edge 1. Now how much will be the radius of this particular fillet, that is given as 45 millimeter. Here we have selected this one. By putting this value, we have seen it is appearing as the same, appearing as good. So we have selected this particular velocity, this particular value for this filleting, and after giving the fillet you have to select this tick. So this particular fillet will be after completing this fillet, then again we will go for the filleting of the another one. So during this time, what can be done? This you can press the button of this mouse and press and drag, so that this view of this particular figure, it will be tilting, rotating. So accordingly you can find out where you need to give that particular fillet. You can actually find out the portion where you need to perform your surface editing. So here the second corner, in the second corner itself you have to give the fillet. So after putting this particular fillet, so it will be prepared. Now it is a basic shape. Now what we need to do, we need to provide some angles. Those particular angles actually we have discussed. So there are different types of angles. So pitch angle was there, twisting angle was there. So how to provide those angles? There is another option. So under the feature button, so there is another one option was the flex. So even if you can see this flex button also, this flex button itself will be showing you there is something twisting, rounding is there, means those type of symbol is there. So you will be selecting the flex, so to provide the twist. So that particular pitch angle, that we have already considered during the drawing of the basic figure. So the plane we have selected there, and the coordinates of the plane, initially we have selected plane 1 and plane 2. So position of the plane 1 and plane 2 was selected in such a manner, so that itself it will be incorporating those pitch angle values. So that particular tilting, that has been given there. So now here basically we are trying to give the twist angle. So twist angle, so we will be giving it to the flex. So flex, there are different options are there. You can see bending option there, twisting option there, tapering option there, and stretching option there. Different type of option is there. So we are here we are giving a twisting option. So when you will be selecting the twisting option, this particular axis it will be generating, and this particular axis, this yellow axis, here it will be X, there it will be Y, and there will be Z. And through the mouse you can control the rotation of this particular axis. So you can press and rotate all this rotation, and accordingly this particular basic shape it will acquire some of the angles what is required for our twisting. So otherwise you can directly give this particular value here 20 degree or something else, as well as if you can provide some of the values, the trim angle, trim plane 1, trim plane 2. So if you do it manually, and if you do not have any kind of data, you don't know that corresponding to this dimension I would like to give a twist to my blade, so you can go with this mouse action, or otherwise you can select, if you have exact data you can select these particular values and you can put it here, and you can cross check how much this particular value it is being adopted in this particular drawing. So both way you can give. So ultimately you will be you have to select this tick to consider that particular values and to incorporate these values in my figure. So now again, now next part is the bending. We have three angle, one is the pitch angle, second one is the twist angle. Pitch we have considered through that plane position. The twist angle I have given through the flex, as well as bending also I will giving to the flex, because the blend option also was there. So similarly, blend option I will be giving with the same process, same steps, but here bending option will be there. So this bending option here I have chosen randomly. So this particular value I have chosen, and accordingly this bending has been also adopted. Then you can see to select this tick. So final shape of a single blade with a certain thickness, with a certain hub, with a certain position in a hub I have completed. So after that what I can do now, this one blade with this particular central shaft or hub that has been created. Now my purpose is to provide similar symmetric similar blades, multiple number of blades in a symmetric order. So how many number of blades you would like to insert in this particular geometry, that you have to decide as per your calculation, and then you will be putting it in some array order. So those things here different type of options are there. Here basically it is like a polar coordinate, means we know if 4 number of blades will be there, so angle between two blades it will be 90 degree. So basically we will be following the circular pattern, and if there are something which is kind of array like this, so then we would like to select the linear pattern. So here we are selecting the circular pattern. So circular pattern I have selected, and this with this particular blade. So here 360 degree, how many number of blades you would like to give? 4 number of blades. And then what is the option? What is the body? Body I have selected. That body already has been flexed. Already flexed body. The body I have already flexed. So whenever I will be selecting it with the click, so it will appear as a flex. Because if you see here, what we have done, boss extrude, that means I have given the thickness. After that, why I have done, I have given the fillet to one edge, then I have given the fillet to the another edge. Then what I did, I have made a flex. First flex was for the twisting angle, second flex was for the bending angle. So everything is there, you can click it here and everything will be appearing. Now third one, last one, right now what we are doing the circular pattern. So circular pattern, so what I will do, even whenever I will be selecting this one, so this flex will be automatically being selected. And since this is 4 given, so automatically it will give you the impression that floor blade will be appearing like this. If you select this green tick, so ultimately it will produce this type of figure. So once these particular figures are being generated, right now those are being generated separately. So basically I need to combine all these things. So individually, initially I have created the hub, then one blade, then another 3 blades. So now I have to combine all these things. So combine whenever there is option, again this will come under the feature. So feature, initially earlier what we did a flex. So now we will be selecting the combine. So when we will be selecting the combine, so what actually we are trying to do? We are trying to add multiple number of the solid body into a same body. There are lots of solid body, and now I want to make it a single solid body. So what will be done here, you can see there are different options are there. Add is there, subtract is there, common is there. So each have different option. Suppose if I would like to suppose there are 2 solid body I have prepared, and their coordinates are such that they are actually overlapping with each other. But if I consider then both are solid body, so in a same position both cannot exist. So one will be actually inside the another. Suppose if I would like to draw this, so its central axis it will be here, my hand central axis that will also be there. So if I put it like this, say my hand is solid, so how is it possible? Unless or until if I tell that this is being inserted inside my hand. So my hand, inside my hand, that is cavity, that should be cavity, then only another solid can come. So those type of addition can be done through the subtraction. So those addition will be subtraction. So subtract option is there. Here what I have done, this is my hand, this is another thing, add it. So it is a simple addition. So this type of combination, combine, it will be done through the add. So similarly there is another common. Common will be what will happen. So suppose this type of section will be there. So it will join separate, this all also will be joining, creating separate body. The common part will be on a separate body. So in our case, common will not be valid. In this particular drawing, either we will be using the add or we will be using the subtract. Here we will be doing the add. So here we will do the add, addition, all the halves, blades, it will be added, and you will use the green tick, and then it will be combine 1. So after combine 1, basically my drawing is complete. So my rotor drawing is complete. Now I have to prepare its environment to run inside the ANSYS. So before considering that, I have to understand some more thing. So this is the picture. You can see this particular picture actually is showing. This is a channel. In this particular channel, this is a vertical axis turbine. This is not this horizontal axis turbine. So this vertical axis turbine, if you consider, so this turbine, if it rotates, so it will form a cylindrical zone. This vertical axis turbine, if it is rotates, so it will form a cylindrical zone. Cylindrical zone you can consider with a liquid. Cylindrical zone with a liquid surrounding the blade, just surrounding the blade. And rest of the part here already fluid is coming in a channel and coming out of the channel. So this is the zone, another zone where normal fluid is entering and going out. Here surrounding this particular rotor and inside this rotor there is also fluid, but this will the influence zone will be cylindrical zone. Now here solid surface, solid object itself is the rotor. So three things we have got. One is the solid object rotor, another is the when rotor will be rotating, its influence zone that will be cylindrical shape for this particular case as well as for our case. In that case, its axis orientation will be something different. Here axis orientation is vertical, there that is why cylinder will be like this, and there our axis is horizontal, so cylinder will be like this, nothing else. So remaining part, the fluid is entering, that will remain the same. So these three we need to draw, we need to prepare properly, and then it will be prepared to transfer for the ANSYS domain. Otherwise, if we cannot do it properly, then it will not be considered, ANSYS cannot compute those particular thing there. So here, this particular picture I have shown is for the vertical axis zone itself. But in our case, this particular cylindrical zone, it will be 90-degree tilting will be there. So this particular part, the fluid zone here, which is just surrounding with the rotor, it is called rotating zone. Those particular part, it will be rotating influenced by this rotor. And this particular part, we generally call it the computational zone or stationary domain. So this particular part, the liquid part, it is called computational or stationary domain. This is the rotating domain, and inside this there will be the rotor. Rotor will be solid body. So these three we need to prepare. So far solid body I have done. I have made a combined one. Combined one itself, it contains 4 blade, 1 harp. Now my object will be to find to prepare another cylindrical zone, which is for that particular rotating zone. That will consist of fluid, but it will be just surrounding the rotor. So for this, what you need to do, just like we have seen, every drawing we will be starting with the plane. So we will start with the plane. So this particular plane, it will have the same your right plane, because right plane itself I have drawn the blade. Whenever we have started the hub, we have drawn it through the front plane. Whenever we have started the blade, we have chosen the right plane. Now also we will be choosing the right plane, so that whenever now right plane is looking like this in this particular picture, when I will select the right plane, it will be exactly like this. Now I can draw a simple circle in this particular right plane, and I can give a depth to the circle, so that it will form a cylinder, and that depth I can give through the extrude. So those things I will show you again, and you can see the minute changes in this particular area. So here whenever I am putting the plane, so what will happen, we are selecting the right plane, and then provide the distance from the origin, because here whenever we have drawn this particular figure, in this particular figure origin was somewhere here, but now I have to prepare a cylindrical zone, which is actually rotating domain. That particular zone, cylindrical area, it should cover this particular rotor properly. It should cover totally and properly. So my extent of this particular zone should be such so that it can cover. So position I need to define. So we will start with the reference with the origin, and then accordingly I can provide the distance as per my drawing. So here I have given some distance, and then what will happen, you can see the plane 3 is created. So in the plane 3 I will start the trace. Right plane I have selected, then plane 3 it will take a name as plane 3. Up to plane 2 already we have done, so plane 3 it will take automatically, and then we will start sketching. So similar way. So whenever we will start sketching, so right now I don't need any kind of line, any kind of curve. I need straightforward circle. So I have selected a circle, and circle center of the circle and center of axis I have to align so that it can properly cover it. So after that I have to give the diameter of this particular circle, or I have to give the radius or diameter in any manner you can give. So there is the parameter option. So using that parameter option you can give the value. Now there is another thing. When you are giving these particular values, you have to keep something in mind. You have to go through the literature. Already there are some prescribed value. In our case, normal rotational domain, 15D to 25D is a optimized value. You can give more amount of the diameter, but 15 to 2.5D, D means the diameter of this rotor. That means this particular, if it is the diameter D, so here we have drawn it as a 1.5D. So this will be the extent of the rotating domain, at least. You can go up to 2.5D also. So here actually what will happen, in this rotating domain, fluid will be entering from any side. Although we have discussed that fluid which is passing through the channel, it will have a certain direction, but here whenever this particular rotor will be rotating, it will be approaching in this direction, straight forward in this direction, as well as from this side also it can happen. So we have to choose the dimension of this rotating domain wisely. Here from the literature, we have surveyed from the literature of the vertical axis turbine. Here we have found that 1.5D to 2.5D is a standard hands-on distance, so we are selecting it here, and we have selected tick option. You have a tick option, and then it will be vanished, means apparently it will be vanished. So in order to see this particular means cylinder, means I have drawn a circle, and when I have ticked it, so apparently it will vanish. So ultimately you have to check it here in the left side. It exists. If it is exists, no need to worry. So what we will do now, we will give you the thickness. Thickness will be more than the length of the hub, so that it can cover. So here our blades are like this. So corresponding to the blade, I have turned it right plane. So I have drawn a circle and I have ticked it. Okay, fine. Circle is considered, and suddenly it vanished. So now I have to check it from the left side, and then I have to give the thickness. That particular thickness, it should be here itself also there should be some length. There itself also it should be some length. So accordingly I have to give the thickness. You have to choose the length of this extrude properly. So here I have selected again the boss extrude option we have selected, and mid plane, and then either you can press and hold this extrude button here, so it will be giving you the direction as well as magnitude, or you can put it here through the giving the numeric value. So accordingly you will be giving the value, and then you click it. So it will be taking the value, and your rotating domain will be complete, and then it will have a name boss extrude 2. So boss extrude, it is the command, and initially boss extrude 1 we have considered for the thickness of the blade, and here boss extrude we had applied for the thickness of the rotating domain, if you would like to define it as a thickness. So now at the same position, my solid object also there, and surrounding solid object, fluid object, this rotating domain is there. So I have to create the provision so that both things exist together. So what I need to do, I need to combine these two. How I can combine? Now this moment, initially I have combined by adding, blades were there. Now here I will be doing it subtracting. So here I will be combining it, and this combination, it will be this combination here we will be choosing the main body. This is the main body. You can select it it will be highlighted as green. So main body is the boss extrude, that particular rotating domain, and bodies to combine is the combine one, that means the solid object that we have created, rotor one. So from main body, these bodies to combine, it will be, what operation will be there? This will be the subtraction. So subtraction will be there. So subtraction of the combined one from the boss extrude 2, that will be done, and then you will be basically clicking the tick mark. So in meanwhile, if you would like to check the internal part of this, because whenever you will be handling this type of object, so what will happen? So you have to zoom out. So internal part, it may be smaller in size. So if you would like to see, so here you can find out solid bodies, because solid body you have prepared. So solid bodies is there. You can click it here and you can find out what is there. So internally you can cross check what is there also. So anyway, so you will be clicking this particular part, and then you can go for combine. After combination, combine 2 will be generated. So this combine 2 will be generated. Now if you would like to see, this particular view is called wireframe view. See, through wireframe view also sometimes we would like to see what is there. So wireframe view actually will show you the physical lines which has been generated in between the contact of the different surfaces. So here you can see this is the line, it has been generated because of the surface. Here you will see 2 lines has been generated because of the thickness. So if there is some error in this particular drawing, then also through wireframe view we can cross check. So this particular view, you can through this particular view you can cross check your geometry, and then you can proceed. So wireframe view you can see here, if you see click it here, so different type of options you can see. So this particular option will give you the wireframe view. Here is the plane view, here is the wireframe view, you can see. Now next is, this is the rotating domain. Now initially we have prepared the rotor. Now there is the part of the competition domain. Competition domain is replicating the channel where fluid is coming in and going out after passing through the rotor. So this is the bigger one, and in generally size of this computational domain will be always higher, minimum 5 to 10 times of this rotating domain. So accordingly we will be discussing in ANSYS. Accordingly you have to select the site. So again we will be selecting the plane, we will start our drawing. So this particular computation domain, it will acquire this rotating domain. That means rotating domain should be inside the computation domain. And this computation domain, again, it can be circular, it can be rectangular. So cross section if we consider, suppose this is the channel. For our case, if I see, this is a rectangle. Suppose if I am talking about turbine installed in the pipe. So the domain you can consider, this is the circular domain. Suppose you have an open channel itself that is having a circular shape, it may be possible. So wherever you have the system, accordingly you will replicate those things in as per the system, means physical system, because ultimately you would like to verify or validate your simulation with the experimental result. So here in our case we have considered our computation domain to be rectangle. Actually when rectangle will be represented as a 3-dimensional, so it will be called as prism. So we have started with this plane. Again we will start with right plane, and again I have to define the position of the right plane corresponding to the origin. The origin is the reference. So after providing this position of this right plane, I will select the tick, green tick, and then here you can see this smart dimensioning I have given that from where it will be given. So right plane has been created. Now on this right plane, now I will start sketching. So plane is, first plane will be introduced to give a platform to draw. Now I will start the drawing. So whenever I will start the drawing, I have to sketch. For this particular time, I could have proceeded with the line, but here straightforward, when I know that my domain is the prism, 2-dimensional represent is the rectangle. So straightforward, I will go to the sketch and I will select a rectangle. Now this rectangle size, you have to define it properly. So whenever we select this rotating domain and this computational domain, so you have to keep in mind distance should be sufficient so that wall effect should not hamper. The wall effect most probably that will be taught in your other part. So that wall effect, it will not, that means the solid wall of this particular channel, that should not hamper the rotation or the fluid which is passing through this particular turbine. Otherwise your calculation will be influenced. So sufficient distance must be there. So accordingly you will be selecting the size of this computational domain. In general, if we have some laboratory experiment set up, accordingly we would try to replicate that particular dimension. Otherwise, if you are selecting if you are considering the natural case, you have to be very careful while you are selecting the computational domain. So this particular computational domain, I have selected the values. So parameters here I have selected, and then I will be selecting that green tick. So once I select the green tick, again that is vanished. That particular rectangle is vanished. Only when that will be appear, whenever I will give the thickness to this particular geometry. So even if that is vanished, but you can see plane 4 already has been created. That has been created to provide this sketch. Sketch was 4. So 4 sketch, that is actually rectangle, and now I will be giving it a extrude value, some thickness. So for this I have to provide the extrude. So for extrude, basically boss extrude is the part. So that particular boss extrude, here I have to give the extrude value. So once I select the boss extrude, there will be option. So from you select the sketch plane. So sketch plane will be there. Now direction, what is the direction? Bind. So these 2 arrow will be appearing. This arrow you can select and drag this arrow, and it will be giving you the random value, or otherwise. Here you can see I have given the drawing as below 300 millimeter, but here I am giving the value as almost 2 meter. So even if I have given it randomly, but you can understand how much will be the multiplication, means magnitude of this computational domain with respect to the rotating domain. So I have given it here like this, and direction also, this is the direction 1. In direction 1 I have given this much, and direction 2 I have given this much. So accordingly you can adjust, you can define in which direction your fluid will be coming and which direction fluid will be exiting. So inlet and exit of the fluid direction, where you will be positioned your rotating domain, that means turbine. So that thing you have to decide, and you have to go through the literature to find out that whether flow is properly developed for testing of this particular performance of this turbine or not. So those values are given in the literature. Through literature review that can be obtained. And another thing, it has been seen that we have collected the literature review, that we have found out that 5D to 10D will be the good value for giving this length of this particular competition domain. So at least 5D to 10D, that will be depends. That depends on the situation. But minimum 5D must be there. So after that you will be selecting the green tick, and then it will be considered. So now this particular prismatic competition domain has been created. Now prismatic competition domain, it inheriting inside this already that particular rotating domain exists. So now both cannot exist until or unless we perform some operation. So we need to do it again, our combine operation. So I have to create the space so that will be inserting into the, but position wise now one is inside another. Rotating domain is inside this particular domain. So I have to go for the combine. So here again feature combine, and in this particular combine, here actually combine 4 has been generated because initially I have started and I faced some error. So combine 3 gone. So by default combine 4 has been generated. I did not change it. So ultimately combine 4 is showing it here. Means combine 3 is missing. That was during the exercise. So combine 4, here the name is combine 4. Even if we are doing the combine 3 operation, combine 4 has been taken as a default. So here also we have subtracting the rotating domain out of the competition domain. That means from prism I am subtracting the cylindrical part. So that is why main body is the boss extrude 3, the third one, the last one we have done. That is the main body. And what we are removing? We are removing the combine 2. So this particular combine 2, that has been removed from the boss extrude 3, and then you have to click tick, green tick, so ultimately it will be produced. Now whenever all these 3 will be created, so this particular pop-up will be generated, so everything is be done. So in this particular thing you can cross check the selected body, which body you would like to select. All these things you can select selected bodies, body 1, body 2. So in this manner you can select. So choose option selected body, body 1. Body 1 incorporates rotating, computation domain and turbine domain together. This body 1 actually computation domain and turbine domain both are incorporating. Whenever we are subtracting, so this particular subtraction inside this already I have subtracted. So whenever already this computation domain is there, I am subtracting this rotating domain. So already inside this rotating domain your rotor exists, so that purpose also done. So ultimately now I can see again from the wireframe view. So I just told you this is the wireframe view. Through wireframe view we can check the whether any line that is creating the problem or not, what is the actual surface criteria. So here we are observing the only rotating domain and this particular computation domain, so you cannot see it here. So these two only be observed for this particular case wireframe view, and because this is the combination 4 wireframe view of the combination 4 I am observing. If you would like to see combination of combine 2, then you could have see this one only and inside this particular rotor. Here I am clicking the, here I am selecting the combine 4 operation only I have done in between the computation domain and the rotation domain. So that is why in wireframe view only these two is observed appearing. But if I would like to see this one, so I have to click it here in combine 2. In combine 2, then your rotating domain as well as the rotor that will be visualized. So anyway, so these two are being prepared. Now what will happen? Now I have to select, I have to save my drawings so that I can call it through the ANSYS domain. So here basically we are selecting IGS format to, so IGS format I have to select. So rotating domain you will be saving it separately, and then your combine 4, that will be computation domain, and then ultimately it will be appearing as computation domain and rotating domain separately. So these two file will be called in the ANSYS, and ANSYS analysis we will be discussing in the next class. That's means next my tutorial will be tomorrow second half. So tomorrow second half I will tell you the how this file will be called and how those things will be making setup in the ANSYS, and what will be the post-processing criteria, in which way you will be doing all these things. Again I am telling you all those exercises require lots of time. I have put all the steps here in the PPT. I will share the PPT later, but if I could have done in live, it was not possible within this particular time. So that is why we have presented our this particular lecture, or you can say that is not lecture actually, by characteristics this is a tutorial. I could have actually, we have mentioned it in our document also. So we will be doing it some pre-loaded case. We cannot do it in live. It requires lots of time. Otherwise we could have eliminate some of the steps to show you live. So we prefer that we will be showing you all the things in this particular manner. So hopefully it will be helpful. The links, the references and the notes, all these things will be provided later in PPT form, not in PDF form, PPT form. Okay. So if you have any question, you can ask me. Or right now, if you cannot remember or identify this particular anything, so you can mail me even after completion of this course. I will try to give you the answer. It will be better. Any question? Okay. Then we can close this session.